In this video, we'll be taking a look at how to save cost further with Gemini using the batching mode and why you would use this, when you would use this, and how to do this. If you've made it to this part of the video in the series, you are the real one, guys. You are the senior software engineers. Thank you so much, because this has really helped me to solidify the knowledge I have in Gemini. But without further ado, let's get into the video, and then we'll discuss at the end of the video. Make sure you stay. We'll be discussing the capstone project we'll be building, and I'm sure you'll be so excited. Let's get into the video. As usual, guys, all the links to the notebook and to the resources we've been using will be available in the description. If you've not run any of the tutorials or any of the ones we've covered previously, I beg of you, or I plead with you, make sure you test this out, because I want you to solidify this knowledge. You will need your Gemini API key, as we've already required in other parts of this video, right? And you could get one from the notebook, directly in the notebook, and you ensure that you grant it access to the notebook. For setup, we would need the Gemini API client. We would also need access to that key, and for the model that we'll be using the Gemini 2.5 model. What is batching and what is the batching API? This is a concept that does not have anything to do with Gemini. In general, batching is a process where you asynchronously process data for later use. This is useful in situations where you are analyzing data or you need to perform some form of processing on the data, and so you could batch all the requests at once, do it asynchronously, and then once the response is available, you could send it back to your clients or your users or save it somewhere. And this is something similar in Gemini, where Gemini has support for batching, which is a feature that allows you to process workloads asynchronously. Say you're building applications that continuously interact with large contents of data, but the SLO of these applications is quite low. Say for example 6 hours, or say for example even a day, you're processing and analyzing data, and you don't need to provide this response back to your users immediately. This is a very good use case for batching, because then you could take the enormous amount of data you have, pass it to Gemini, have it process it, wait and pull for the result of this processing, and once it's available, you can then use this response. Why? This can dramatically reduce the cost of using Gemini. Again, cost reduction. I really love how these companies like Google and OpenAI continue to consider the cost of using their services, and they continuously provide some way for you to control the cost of your usage, and you could reduce the cost by 50%. It's a useful where real-time response isn't needed, or you require deep analysis and evaluation. How do you enable batching, or how do you do batching? You can create a batch request through two modes. One, the inline request, and this is just a process where you generate a list of generate content request objects that you include in the request to Gemini to create a batch workflow. Or you could also specify a JSON ELF file where each line corresponds to a request containing a list of generate content objects, and this is recommended for large workloads. In this tutorial, I'll be showing you just the inline request, but the file request is very simple. I'll show you an example of how to do this. So we'll be working with this data where we have a list of these companies, we have an ID, we have a company name, and what we want to do here is we want to process this information and have Gemini basically enrich this company data with some additional information, like what is their aliases, what's the mission statement, and what's their value. And this video will basically be using everything that we've learned in previous videos. One, for example, we've learned about structured output, and we'll be using this in this video. We've learned about file API. If you're using the inline request, you'd have needed to upload your file. Batching is a concept that would require file uploads, right? And many more applications like tools. We will be providing tools for Gemini and even system instructions, right? But here we define a pedantic model that we'll be using, and here I just define a prompt that will be used as my system instructions, and here I'm just telling Gemini that I want it to enrich this data using this information, and all we need to do is then build an inline request. Don't forget, I said you could create a batch API request through inline request or file request, and for the inline request, and all we need to do is to create a generate content array And the way you do that is you specify your content, and your content contains an object of the role, the parts, and here I specify the text is basically the prompt I'm creating here, and I pass it the company name and the company ID because we're iterating over each company. And this company is just a key that I want to use to identify the type of job that we're sending to Gemini. One of the things I wanted to do in this tutorial is to provide Gemini the Google search tool so it could use real information and not the information in its training data. But there's currently an issue raised where when you provide tools in the Batch API, Gemini is unable to use these tools correctly. It's still an open issue, and I'm sure the team at Gemini is still working on this. Hopefully they could fix this soon so we won't be able to use real information. But here we specify the response type and response schema of company side. Before sending this request, all we just need to do is call the build company inline request, and here we see that it creates an object of content role user. You are a precise research analyst, gather up factual information about the company, Greenwich Leisure Limited, and using reliable public sources. And then all you need to do is create your batch request, and the way you do that is you use the Batch API available in the Gemini SDK. You call the create function, pass it the model, pass it the source. Here you would either use the inline request or the file you've previously uploaded, and then you pass the display name so you could use it to identify the batch that this request is specific to. And then once you call this request, all it just does, it creates a batch job and it provides you a batch ID. So now you've created a batch job. But how do you monitor the status of the request? And the way to do this is that you basically have to poll for the status of the batch job, and there are about a couple of statuses. And we have the job state pending. This is a status where the job has been created and is waiting to be processed by the service. You have a job state running. This is where Gemini or the Google team is then processing your request. And then you have the job state succeeded. When your job is successfully processed, this is the state that it will be, and you can then retrieve the results. We also have a job state failed, and it means the job failed, and then you could check the error details for more information. You have a job state cancelled. This is where job was cancelled by us. And you also have a job state expired. This is where, say for example, you created a job but it either successfully executed or did not successfully execute. This is where it was expired because it was running or pending for more than 48 hours. And this job will have no results for you to be able to retrieve, and you can try submitting the job again or splitting up the request into smaller batches. Again, while you can send a batch request with enormous data, there's still a limit. I will be covering that limit later. The way for you to check the job status is you need to just poll and just check if your job is in any of these states. If it's in any of these states, you retrieve. If it's in any of these states, all you just need to do is check the response. And here we see when I executed this previously, job not finished, current state is pending. And for example, it didn't even take time for this job to process, and we see here job not finished, but then we see that the state after a while changed to running, and after a while it changed to succeeded, because here we're checking that if the job is succeeded, failed, cancelled, or expired, we're going to break. But then if there is a successful response, because the response will only be successful if the job is successfully switched to the job state succeeded, and then we just print the results, and we see here that it successfully enriched all the companies are provided with some information, or most of them actually. There are some companies that can't find information because this is not using real-time information. You created a bad job, but you don't want the bad job to execute anymore. What you could do is you could cancel it, and all you just need to do is, after you've created your bad job, you use the cancel API and pass it the bad job that you previously created, the name, and that should successfully cancel the bad job. You could also delete a bad job through the same mode, but use the delete API, and that will delete the bad job. Right. So limitations: both inline and input files are supported. Use input files for large requests. Pricing is 50% of the standard price. Completion time of 24 hours response turnaround, but could be completed much faster. As you could see, that was very fast. But if you had a very big request, or say the complexity of the task higher, we would have job execute longer. You should also use unique name to identify requests in the batch, and batch requests are idempotent, so don't make multiple batch requests with the same data as it counts as two separate requests. What this means is that, say for example, we executed a batch request with this data. If we execute it again, this is not going to be seen as a single request, it's going to be seen as two requests, and that counts towards your cost. And if you have very large batches, again, I'm reminding you, split it up to improve turnaround time, because if you have very large workflows and they are complex, by splitting it up you ensure that you get results much faster, and you can also handle situations where one of it fails and you can retry only that subsequent batch. So recap guys, we've seen how batching works in general and how it works in Gemini. We've discussed the benefits of batching, cost reduction, suitability for non-real-time workflows. We've looked at how to create batch requests, how to retrieve data, how to monitor it, and we've understood the different batch job states. And then we've also retrieved results from the completed batch jobs, and lastly we saw how to cancel and delete batch jobs. And these are building blocks you'll come back again and again when working with Gemini's batching capabilities and even Gemini in general. I know I keep saying this, but trust me, this is something that you would use over and over again, and that will be so useful for you. It's been so useful for me because this is all the concepts I've used in Fly Labs, which is a tool I built to help anyone practice with interviews. Thank you so much for watching guys. This is the end of the series, but we're not going to stop here. Now that we've understood all the available features in Gemini, we'll be building an application where a user can provide a video, say through a link. Say for example, they take a link on Instagram, on TikTok, say it's a recommendation for things to do in Thailand. We will pass this video to Gemini, have Gemini extract all the useful information from this video, and then in later videos we could even extend this application to support analyzing the video, to understand the different elements, or to even identify things. And this means that for such a project we'll be using we'll be using the file upload, 2 we'll be using structured output, 3 we'll be using video understanding, 4 we may be using batching. Say for example we want to support getting a large amount of video and processing this later. We would also be using the Google context caching. Say for example we keep analyzing the videos but we want to save cost, we would definitely be using the URL context and also the grounding. Say for example we want to give the user direct information, say it's information about books that were mentioned in the video, we want the user to be able to click on a link and it takes them directly to where they could find the book. These are very useful concepts that we've covered throughout the tutorial, and I can't wait to show you this project and I can't wait to share it with you. We'll have so much fun. Thank you so much for watching. If you love this, my name is Timmy and I make videos like this. You watching, you liking, you subscribing helps me, it encourages me, and it teaches me. If there's anything I'm not explaining well, please leave a comment, because I'm learning, you're learning. Let's continue to learn together, and I'll see you in the next videos.